Hi, my name is Meghan Rieu-Werden. I work for the Advanced Research Group here at Wolfram Research, and today I'll be talking about data management for machine learning. So today I'm going to talk about data management for machine learning. So in this talk, you're going to get a high-level view of the data management solutions that were chosen for our machine learning team here, and hear the rationale for such choices. And then I'm also going to give a quick tour of the built-in Wolfram language functionalities that will allow you to easily interface with the external data storage systems. So currently we have Mongo Link, external storage, and AWS Link. So the first kind of choice for data storage is, do you use a flat file system? Do you use a database system? So flat file system would be something like just using your documents folder to store data. There's a lot of issues with that. You're going to have data probably in like CSV files. That's going to be a problem. Also, probably you would organize that by data set. But what happens if you wanted to query by the type of data that you have? So if you have images, or if you have text or audio, or what happens if you want to search by task type? It's going to be really difficult to do that if you use a flat file system. So most people use a database system, which is queryable. So that's going to help you with sorting, what kind of data that you want. Also, the largest data sets are not going to fit into your computer's memory. So probably you would want to do a query to limit which data you're going to select. So you'd have, especially for machine learning, you're going to have training data, you're going to have test data, and you're going to have validation data, and you're going to want to be able to query based on that. So the next choice that we had was, do we use a traditional relational database management system like SQL, or do you use a NoSQL or document store kind of a system? So we went with a NoSQL system. One of the benefits is that it's schemaless. Now that doesn't exactly mean that there is no schema. You don't have to adhere to a schema, but you're going to want to organize data in some sort of logical way. You're not going to want to dump everything into the same table or collection. And so what it does mean is basically that the number of fields, the content and size of the document can differ from one document to another. So for example, this is, I believe, the ImageNet data set. So if you notice here, we have two different documents, and they can have different fields in them. So this document does not have object data, so it doesn't have a bounding box. It doesn't have a class for each of the items that are in the bounding boxes. And so the benefit of this is basically you don't have to use null values when you don't have a value for that particular variable. You can just drop the variable entirely. You can still use null values if you'd like to, but it's not necessary. There are validation rules that you can use to enforce a schema. So if you want things to be a certain data type, or you want a field to exist or not exist, you can kind of set up what you want it to be. And then if you try to insert documents into the collection, it will reject them based on the schema that you've set up. The document structure is also compatible with that of a nested association Wolfram language. So in MongoDB, it's actually sort of a JSON style document. So it actually looks like this, whereas this same document in Mathematica is going to look like this. So it's a document-oriented storage. So it's stored in the form of JSON style documents. So this image kind of shows you in a traditional relational database management system, you would have your data normalized. So you would have, you might split up the data based on, if you had city and state, and you might want to have that in a different table than the address. And the issue with that is then you have to join all the data back together in order to have some sort of logical document. In a document store, all the data is already joined. So you notice here, this is sort of a sub document of this. So you can have multiple different cars for the same document. This makes it easier for developers because they don't need to actually join anything. They can just look at this. Everything is completely logical. They know exactly what the structure is. And you can nest these as deeply as you want to. So you don't have to normalize it. It's also very easy to scale out. So because of the document structure, you sometimes with a relational database, you realize that all of a sudden you're going to have to add another table, and then you're going to have to rearrange your entire thing, and that's going to be a pain. So you can just very easily horizontally scale out from this. You can also do replica sets, which basically means you can have basically a backup of each thing. So you could do 3 different sets, and then if one goes down, automatically they'll they call it like they vote on which one is going to be the primary, and then the primary gets added. You can also do sharding. So rather than having 3 sets that are exactly the same, you can split your set so that you have one piece one place, one piece another place, another piece. So we specifically, there are a lot of different NoSQL or document store systems, but we specifically chose MongoDB because of its popularity. So you can see here in all of the different document stores that there are, MongoDB is by far the most popular one. And it's actually, if you go to this website, you can view all of the different database management systems, and it's not far behind things like Oracle and MySQL and things like that. So because it's popular, it also means that it's going to be robust. You've got millions of users rather than just a few. So it's easier to get help, and it's easier to make sure that the software is working properly. So that's where we store all of our data. For files, you can store files in a database file system, but we've chosen not to. So one of the reasons that we chose not to is that it's more complex and you have to sort of do more planning. Whereas with things like with AWS, which stands for Amazon Web Services, and S3 stands for Simple Storage Service. So with AWS, you can store 1 file or you can store 1 million files, and you don't have to change any of the configuration. You can just do what you want with it. Also, it's really helpful to have an object storage system because the size of all of our files combined could be on the scale of tens of terabytes. And so it's very difficult to fit all of that onto one single machine. And the size of, basically there's an issue with transferring large volumes of small files. There's a link here that you can read about it if you're interested. But basically, AWS has figured this out and has done a lot of engineering into making it so that you can quickly move around a lot of small files or a lot of large files. And data transfer to EC2, which is Elastic Cloud Compute, is especially fast and it's free, and I'll get into that, what that is in a moment. AWS is also geographically distributed if you'd like, and they guarantee basically 99.9% that your data will never get lost. Also, not specific to AWS, but a thing that we do in specific is for duplication, basically, to avoid duplication, we name our files by a hash of their contents so that we don't have, because sometimes basically there's a lot of duplication across machine learning data sets. So a lot of the same images that are in ImageNet or in MS Coco, and rather than having 2 copies of those images, if you name it by the file hash, you'll always have a unique ID for that. And then for training, data ingestion, benchmarking, what have you, we use AWS EC2, which is Elastic Compute Cloud. And basically, when we were considering this, the consideration was: do we use our own equipment or do we just rent space whenever we need it on a cloud service? In the past, we have tried using our own equipment, but there's a couple reasons not to. So training demand can be highly variable around freeze times. We have a lot of developers that are trying to train a lot of things. They're going to need a lot of time. And then there's other times when we have no training. So rather than let machines that we own sit idle, we just rent space when we need it. And this is basically exactly the use case for EC2. We have, like I said, we have multiple users. and the configuration can be difficult. Some users are going to need one version of Mathematica, some are going to need a different version. It's hard to tell what you're running at any given time, and you don't want to mess up other people's trainings by changing the configuration on them. So if each user can control their own machine, they can start it, they can stop it whenever they need it, and they don't have to worry that they're messing somebody else up. And also in terms of hardware trends, generally when you train neural networks, you're going to want to use a GPU, which is another reason to use EC2. GPUs can be very expensive and they're rapidly improving. And so rather than buying an expensive piece of hardware that is going to then become obsolete pretty quickly, you can just pretty cheaply rent space or rent an instance on EC2 and configure it however you want with as big or as little of a GPU as you want. Okay, so next I'm going to show you some of the built-in functionality that we have created around these choices. So there's something in available in 11.3 and higher called Mongo Link that will interface with a MongoDB instance. So if you have a MongoDB instance installed and running on your machine, you can connect directly through Wolfram language rather than having to use either their GUI for it or use PyMongo or something else that interfaces with it. You can use it right from the Wolfram language. So you can see here, basically we have a connection function. So we can do this, and you can hard code the password if you'd like into the connection, or you can put in $prompt and it will come up with a prompt for you. You can add it in. And then basically with this, I'm just going to show some of the very basic functionality. There's a lot of functionality in here. Pretty much anything that you could think of to do with a database, insert, update, delete, things like that, queries. So you can see if we can get all of the databases that are available to this user through this client that we just created. So we have our machine learning data. And also I should note that for our database, we've chosen to keep it behind our company firewall. So you would need to be on VPN, but obviously if you're using your own instance, you don't need to do that. You can also connect to a database. So once you see which databases are available, you can then connect to the database and then use that to view all of the different collections that are within it. A collection is akin to a table. It's the same kind of thing. So basically, we have a bunch of different data sets. We also have a special collection called metadata. So rather than put all the metadata about it, so where it came from, the rights, the different data types, things like that, rather than duplicate that across the entire collection, we just keep it in a separate collection called metadata. You can view the metadata for any collection that you've got. So we can, if we wanted to, we could view it for a different collection as well and see, a bunch of information about it. And then you can use this to basically query. So if you wanted just image data sets, you could query based on that. Or if you wanted just classification data sets, you can query based on that. And then, so if we wanted to connect to one of these collections, this is the syntax for that. There's something built in that's called the aggregation pipeline. So you can do a lot of different things with this. One of the very basic things you can do is just get a random sample. But there's a lot of things that you can do with it if you're interested in reading more of the documentation. So this is the CIFAR 10 data set. So it's just, there's just 10 classes. You can see we've got the file is named by a hash of its contents, and it's stored on S3, which I'll show you in a moment how to actually get that file that you want. So this is just a sample of that data. There's also the one place where we sort of, we don't keep all of the data in one collection is with the file metadata. So there's a certain amount of data about the file. So the hashes, the format, whether it's color, whether it's black and white, the dimensions, things like that. It's a huge amount of data. So we actually keep it separate, and then you can join it back together if you need to. So then if you were going to write a query for the, whatever script you're going to use for training, you can do it this way. So the syntax is basically Mongo collection find. You put in the collection. This is the query. So we want just training data. And then there's also something called a projection, which basically you can decide which variables you do or do not want to see. So if you say false, you won't see it. If you say true, you will see it. So that's probably what if you're going to want to train with this data, you're going to want to get obviously the training data and not the testing or validation data. And then, this actually name has changed. Sorry about that. So we have something called external storage, which interfaces, which interfaces with S3 specifically. It's we may add other systems to it in the future, but currently it's just for S3. So it's a multi-threaded downloader using the Amazon C++ SDK. It will be available in versions 12 and above. It's not going to work on the build you have for the conference, unfortunately, but it will work in the released version of 12. Currently, this is internal functionality, so there's no official documentation available. It is subject to change. And it's probably going to be exposed via Service Connect in the future. So in order to use this, first you would have to get the Packlet. You would also have to have an AWS account, and you have to configure your credentials on the machine that you're using. So if you're using your own machine, you would do it. If you're using EC2, you're going to want to configure on that machine as well. And then there's a link here if you're interested in seeing how to do that. So for this, basically, you just do a very simple S3 connect. We've established a connection, and then we're going to go back to our MongoDB data to get to get the data that we want. So we're just going to get the training data here. It's just going to take a second because there's about 20,000 files in here. We're just going to show us 5 files right now rather than downloading all 20,000. So here's the file names that we're going to get. And then all you do is S3 download, tell it which bucket it's in. So buckets are it's essentially a folder on AWS S3. Tell it the file names that you want to use, and it will download them. And then if you just do import, you can see the files. I know they're very small and they're very low resolution. But yeah, so you can get that, and then you can use these files to restructure your data in whichever way that you'd like to restructure your data. And then lastly, I'm going to show you AWS Link, which is available in versions 11.3 and above, but is also still currently internal functionality. So there is no official documentation yet, and it is subject to change. I should also point out that through AWS Link, you can access both EC2 and S3 right now. Probably the S3 functionality is going to be taken out and replaced with the external storage functionality. So again, you're going to need an AWS account, and you're going to need your credentials configured, but you can just simply connect to the EC2 client. And there's a lot of things that you can do in here. There's a lot of functionality in this. You can see what kind of images you have, which are basically, it's a base configuration that you would launch your instance with. You can see what kind of security groups you are. And again, on AWS, you can configure certain security groups so that, for example, you can access different things. You can, tighten up security depending on what you want to do with it. A key pair is something that you're going to need in order to access it. Basically, instead of providing a password when you log into EC2 instances, you have a key pair. So you have a secret key and a public key. And so you can see these are all the different keys that we have in our system currently. You can also view the names of available instance types. So if you go to this link, you can see what these actually mean. So it's basically like a configuration for a certain amount of RAM, certain amount of CPUs, GPUs, whatever type of machine you want to rent. This is how you would figure out which one. And You can also do a lot of things with these. You can create an instance, you can delete an instance, or create images, security groups, things like that. And you can also launch an instance. So normally you would have to go, oh, I forgot this one. No, I did that one. Sorry. Normally you would have to go through Amazon's website and go to the console in order to launch a machine. But we've built something into the language so that you can do it straight from from Wolfram language. So you can create an instance. You just have to provide it with the client, the AMI, what type of instance you want, the key pair that you're going to use, and security groups, I believe, is actually optional. There's a lot of other options for this. So, for example, if you need to, you can attach a second hard disk, which is recommended if you need more than 200 terabytes of space, because a root volume won't configure properly. I've tried this before and it's bitten me. So yeah, a root volume will not configure properly. It'll only mount 200 terabytes of it, and then whatever else you won't be able to access. So if you need that, you can configure it so that you have an extra hard drive. You can also attach an IAM role or security groups, both of which are used to deal with permissions. You can also launch spot instances, which are essentially, rather than paying a set price for the instance, you pay a lower price and tell it, it's kind of like bidding on eBay. You tell it how much you're willing to pay right now, how much you're willing to go up to, and if somebody else outbids you, then you get kicked off the machine. So it's a very risky thing to do. If you're doing a really long training, you don't want to do that. But if you're just using it, it's a way to get basically cheaper machines. The other thing that you can set when you're launching an instance is the region or the subregion that you'd like to use, which you can read more about. So we can actually launch an instance straight from Wolfram language. We can then tag that instance so that everybody knows it's my instance and they can't delete it. And then we can get the shell command that we would use to actually, so if I put this straight into a terminal window, I can just access the machine that I've just created, which I won't show at the moment. And then you can also terminate the instance, so you can shut it off straight from the Wolfram language rather than doing it through the website. So putting this all together, basically, if you wanted to, say, train a neural network on EC2, first you would determine what kind of data that you want using Mongo Link. So you'd probably, on your local machine, figure out what queries you want, figure out what data you're going to use, and then you would create a script. So you would connect to Mongo Link, do whatever query that you want to do, then download the accompanying files from S3 using, sorry, I forgot to rename that again. I will repost this, this notebook with the updated names. And then depending on what you're going to want to do, you might want to restructure your data. So you might want to have it go straight from the image to then what class that image is. And then you would train or do, you would set up your script so that you can train or do whatever it is that you wanted to do. Then you would launch your EC2 instance using AWS Link, copy your script onto the instance, and then just run the script. And that's basically how you would do it. So we do have the built-in Wolfram language documentation for Mongo Link. We unfortunately do not have it at the moment for the external. I can't delete that at the moment. But yeah, so basically you would have to use the question mark syntax for this, which then you could get. That's weird. Okay, well that usually works. So this would basically, instead of a documentation page, it would just show right here in the bar what. No. Yeah, I'm not sure why that's not working. But yeah, normally you would be able to see how to actually use that function. And then, so the same thing goes for the AWS Link documentation. And you can see there's quite a bit of functionality in there. And then I also just added a reference to the AWS documentation, their official documentation. And that's all I've got.